CLion, a cross-platform IDE for C and C++. Download now.
Thank you for coming. This is a subject, I always organize my subjects around conversations I have with real people about real problems and real headaches. So don't let the abstract title kind of fool you. This is very much for points for home kind of talk. And if you're listening to this, I want you to take away things that you can use for yourself, things you can use when talking to your colleagues about how to approach C++ projects and the interfaces that come along with those projects and the design thinking we have to do while designing those interfaces, and how that helps us affect the way we do our normal engineering work, right? So those are our other C++ interfaces. While we're shipping our C++, we have to think about more than just the C++. So hi, I'm Bret. This is today. I am a lead of the C++ infrastructure team at Bloomberg, where we have many, many engineers and many, many projects. So one of the challenges we have to deal with is how do we effectively scale that sort of operation? When you have many levels removed in the organizational structure, in time zones and different things with another team, how do you effectively collaborate with your C++ code? You can't just walk over to that person's desk and say, what was that? Why did you do this? How do we fix it, right? So we have to come up with ways to scale that teamwork. So a lot of the lessons coming out of this are things we've discovered and chewed over and refined over the years as we deal with that kind of a thing. Now you might think to yourself, I don't have a big code base, Brett. It's just me and my four best friends hacking on something. But if you're like me, or like most every other engineer I talk to, you do have limited time, and then you do have a limited attention. So you don't have all the time in the world per se, right? So this is also about being efficient about how we work on our code. Okay, so quiz. I have a lot of time, by the way, in this talk. I purposely kept the slide count fairly low for how long the talk is. So let's feel free to interject and ask questions and ask me to slow down or explain better. First audience interaction of the talk, though. Why doesn't this compile? It's on a piece of paper. That's right. The problem is someone drew this in some drawing app and they just wrote C++ code. Now, is this valid C++ code? Hash include OStream. How does hash include IOStream? Standard in L. Oh yeah, it has a stat that does compile though. But yes, you shouldn't use that. It's not my example. Yeah. Right, so this is like a PNG file, which, granted, like AI can probably understand this C++ code now. I'm not an AI expert, and I almost certainly could transcribe it and then compile that. But this is actually, according to ISO, at least a standard or two ago, if you squint, this is valid C++. It adheres to the C++ model of what C++ is. But if someone handed this to you in a pull request, you would say, what? Like, please try again. Give me something I can actually use here, right? And so that's a little kind of what this talk is about that problem, is that you can't, it's not just about the abstract model. It's not just about the squiggly lines that we can come up with. There's something more deeper. There's a more deep requirement, a more like up in your face requirement even about how your C++ needs to be delivered. So there is a credit on this. This is one of the more popular C++ questions on Stack Overflow, by the way, just because it's funny. But there is actually a deeper point here, and that's what I'm getting at. So what we need isn't just good C++, we need good C++ projects, right? We're not shipping ISO UTF-8 strings to each other. We're shipping projects, right? Like if someone hands me a few source files, I'm like, okay, I can't really do that, especially at my day job. We cannot have engineers copying and pasting each other's source files across different kinds of projects. We need them to ship projects to one another. And so we're going to explore that a bit. So there is actually analogies you can use. So good news is you don't have to come from scratch. Like a lot of the principles we already know from our design experiences, maybe you've seen talks, maybe you've read books over the years, actually apply really well here. The same kinds of ideas you might use in your object-oriented programming. The same kinds of ideas you have when you discuss whether something is a good change to merge in a pull request. The same kind of ideas even in the loftier functional programming paradigms you might be used to. Like you could go through this and say, that is a monad, that is an applicative functor. You could say that is dependency injection, that is inversion of control, and you would be right. And so what I'm asking for is that kind of thing. Think about polymorphism when it comes to the other files in your C++ projects, okay? So don't worry, this is not a like academic, no, if only we had spherical cows talk, that's like, we'll see it through the rest of the talk how that actually applies in more concrete ways, hopefully gives you a good feel for that. At the same time, there's a lot of challenges here. There's a lot of different things that you need to do with your projects. And that's partly why this is so overwhelming. It's like, okay, but I have like sanitizer things and I want my static analysis to work and people keep telling me to use sanitizers, but how do I get that to go? And I think part of the problem we've had with supporting all these things is exactly that design issue. It's just like our spaghetti code. If you have all kinds of complicated loops and conditionals and ifs and jumps and go-tos in your code, it makes it very hard to use that code in a lot of different places. It actually gets easier if you're careful about presenting clear like interfaces to different parts and different use cases. And there's something similar going on here. So what I'm saying is let's explore this a bit, but it actually gets a lot simpler if we don't try to support all those things one at a time. Instead, we try to find the right abstraction, and we use that in different places. So the roadmap is fairly simple for this talk. We're going to talk about some of those concepts just to help set the stage. Then I'm going to go through some examples of the kinds of principles, the do's and don'ts that you're going to want to wrestle with on your own with your teammates, but it'll help you think about it from the design perspective and not just how do I get this PR to land perspective. And then most of the time, people also want to say, okay, yeah, that's great. I kind of get your principles. Maybe I get the concepts, but just show me something. Show me something I can look at, I can mimic, I can learn from, I can play with. And that's where we're going to end up at the end of the talk is a very practical, yeah, literally go to this repo, see how we're wrestling with these problems, jump in with us, help us get better too, right? So now we'll start with the concepts and a little bit of theory. Again, I'm an engineer. I'm not a mathematics PhD or something like that. So you'll have to excuse me for my nuts and bolts approach to these things. But I thought it might be good to illustrate these concepts by talking about, again, context we're already familiar with, perhaps from software engineering, let's say design by contract, right, which is pretty well known. It's been referenced already this week in some other talks. So we have to do some definitions just so we all know what we're talking about. Especially in this space, there's a lot of vague definitions for things. We're just for this talk, when I say project, let's just talk about a source release. So let's say a particular Git commit, or maybe a zip file or a tarball of that particular Git commit. Right? And what's inside there? Well, you have build rules, of course, of your source code. You might have some tests, might be in various different languages even. Right? A lot of my colleagues like to use Python to test their C++, for example, in different ways. It'll actually include READMEs and things like that too, and that's all relevant actually to this talk. Let's talk the outline of a contract. So this is very rough crash course design by contract discussion, just so we're all on the same page. I'm sure someone can give a much better version than I can. But for the purposes of this talk, we're just talking about the basic outline. So you have some sort of a precondition. These are the givens when you're about to do something. There's an operation, which is what you want to do. So those would be describing like when you do something, right? And then the postconditions are what happens after. So that would be, and then this happens, in that kind of a statement. And again, the challenge is like, maybe we should try it, right? So I'm going to try it. So I'm going to use the example that we'll get to at the end of the talk. So if you see the project, Beeman project exemplar, this is what I'm going to be using throughout the talk, just to be consistent. And so the preconditions are hopefully pretty straightforward. In fact, they might be so obvious you don't think you need to say them, and some people don't because they don't have a README or something, right? But it's important for different contexts, for automation tools, perhaps for AI training programs and things like that, that you be somewhat explicit about these things. So let's say, because I want to be really sure that you get something that works for your context, I'm going to be specific. I'm going to say, I'm going to use not just some Linux. I'm going to say I'm going to use this Ubuntu from one of these releases. I'm going to say the build requires particular build tools. I'm not going to let you discover, oops, cannot find Ninja on path. I'm going to say you actually need to have the Ninja build Ubuntu package installed. That is the name of the package that provides user bin Ninja on Ubuntu. I'm going to say you need to be in the directory such that this environment variable is a working copy of the exemplar project. Now, I didn't say git clone. You could actually get one of the tarball releases, and this should work as well. The operation, let's say build with CMake. This is a project that supports CMake, so this is what you can do. If you read through the README, it says you can use this command, CMake workflow, GCC debug, and it will build the whole thing. So I know a lot of people get frustrated with CMake. Well, good news, there's modern CMake mechanisms like this where you can just get the one-liner and you get the end-to-end treatment. And then I added one more line, which is to stage and install. So like if you wanted to actually install this project in a container or in a more likely in a packaging kind of workflow, that's the step you would do. Most people wouldn't use this command unless they were troubleshooting something, but it's very common to use by the package manager. So when Ubuntu perhaps would produce a package for this project, that line would show up somewhere or something very similar to it. And to expand it a little bit, this is what the workflow command would look like. So maybe it's a little mysterious to you, you hadn't seen it before, but it looks like something you should be familiar with if you've ever used CMake ever. There's an initial step where you create a configuration. There's a step where you do a build. There's a step where you do a test. And then again, that same install command again. I guess as a small tangent, it's worth noting that this project supports any number of C++ versions, like the versions, like so you can use any number of versions for this project. There's some restrictions that were documented in the README, but you can actually specify that here. So if you wanted a C++ 23 build, there you go, you put 23 in there. But for the operation we're talking about now, we're going to be talking about a C++ 20 build. And then the post conditions should not be surprising. Everything should exit not zero. Your test results are in the test result file. Well, I didn't mention that, did I? Well, I didn't actually put that in there. But there's a flag that I left out in this slide that is specified in this slide that will tell you that you get an X unit, J unit style output from CMake. That's baked into CMake, by the way, so that's not something we added in. And then the files will exist in the staging directory, and you'll see these files, and that would be the kind of contents that you would show up in a Conan package, a VC package, an Ubuntu package, a Debian package, an Arch package, all of the above. All right? So everyone's like, okay, Bret, you just walk me through how to build a project. Like, why is that important, right? Because these contracts need to be communicated to different people, different things. So we have to think about what they need to hear and with what precision. So let's talk about that as a group, right? So let's say I had all these steps all laid out for a project, and I've defined them really well for myself, my team. Maybe we have a standard document of some sort. How would we communicate that to somebody? How would you communicate that? This is not a trick question. Okay, so like how would you communicate to your coworkers, perhaps, that this is how the project builds? README, of course, is an obvious answer. And yet we don't always write those, do we? So no, it's actually really important. And this is something that was interesting to me. Earlier this week, we had an interesting talk about AI and how it gets to be better about helping you with your projects if you're more explicit with comments. And I would say that's probably true of these kinds of documentation as well. If we're very specific, you don't have to be like precise, like script precise, but if you're specific to say this is your build workflow, and then you tell an AI agent write me a script to build this project, it can reasonably help you. If you didn't have that instruction, it would hopefully parse your CMake. I'm not particularly good at parsing CMake, so I don't know why I would expect an AI agent to be better at that, right? So if we're precise about this, we can simplify things a lot. And what is that? Well, we're simplifying an interface, aren't we? It's like in C++, where we went away from hacking around with bits and bytes, and we went to an API that said perhaps decode. Oh, I know what a decode is. Whereas if you're doing a bunch of bit shifting and flipping, it could be any number of things. Could be a mistake even, right? How do we communicate that contracted tool? So I just talked about AI. What about other tools? Are there things that people like to use? Well, yeah, there's like CMake has new presets features. You might have seen that. That's a way to communicate to IDE environments and stuff. Like this is how this project builds with different kinds of options. Your CI system would be calling these commands in a particular order. So it knows how to build your project. And these are actually really important things to think about. Like, is it a good project if you haven't done any of those things? And I would argue, well, it needs some work, right? It doesn't have that interface defined fully. How do we support that contract? Like you say, I have a supported build workflow. What would you do to make sure that's true? Testing, right, and probably automated testing, right? You could manually run that every time anyone pushed a commit ever to your project, but I don't have time for that. I don't know about you all. So what we do is we define these contracts specifically enough for our Jenkins, for GitHub Actions, for our other favorite CI systems, because computers are actually very good at this. So what we're doing is communicating to the computer what the contract is, right? When is a problem a bug? So you get an issue on your repo, and it says, I can't build this. Okay, is that, like, how do you know? Did they do it wrong, or did you do it wrong? Right, and then that's what the preconditions and the post conditions are for. So if they didn't meet the preconditions, they're not currently supported. That's all there is to it. You could think about, well, that's actually a very valid precondition, but that would technically be an enhancement request, right? Or if they didn't meet the preconditions, and if they did meet the preconditions, oh, that's clearly our bug. Now, maybe you promised something you couldn't deliver on, but that would be a design bug or a requirements bug. But that actually helps negotiate things. So when I talk about teamwork at scale, these kinds of things actually help a lot. It gets right to the root of, would you doing something I didn't expect, or you'd be expecting more of me, or some combination of those things. It's worth noting, and I've kind of hinted at this already, that when these contracts change, when they're broken, that actually breaks code, actual code. And it's surprising that people get in their ecosystem so much that they don't think that they think like, well, that kind of breakage doesn't count. That's not a real bug. But it is a real bug. If someone is relying on your project building in a particular way, for example, and you add some new mandatory options to your build workflow, that you just broke all those packaging steps. You broke all those CI systems. No longer at scale can I build all the projects in the company and tell you if you have bugs and that sort of thing, right? So that's actually really important to think about. It's also interesting because that means C++ codes are unavoidably polyglot, or C projects for that matter. There's not a production quality, I'll go out on a limb, there's not a production quality C or C++ project out there that contains only C and C++. So if you are an engineer that delivers C and C++, you have to be at least somewhat comfortable with, yeah, there's a JSON file in here, there's a YAML file in here, there's a CMake list in here. And this shouldn't be a controversial statement, and hopefully everyone in the audience follows along with me. Well, we can discuss a bit if you don't, but like that's something we have to come to grips with. That if you're a C++ engineer, yeah, you have to be comfortable with the language of your build system at some level. But just as importantly, if you break somebody else's use of your build system, that is a bug that you are responsible for. You shipped that project, right? You can team up with some infrastructure team to help you meet those requirements, but it is something you're responsible for because you are providing that contract. Right, so hopefully we're all following along with that. Let's talk a bit about another conceptual idea of like domains of these interfaces. So I'm going to break down some more interesting interfaces, ones that probably deserve a little more discussion. The one we just went through is pretty straightforward. The ones I wanted to talk about they're all related, and they go from, they help take this source project and take it all the way to something that's useful to somebody else. And I'm breaking them down into 4 distinct, I'm calling them domains, for lack of a better word. Maybe someone else can come up with a better one. The idea is that these are all mathematically almost universally things that you go through for almost every project. And again, this is kind of polyglot. This is not specific to C++, but it is something that everyone maybe hasn't thought about all the way. So this is good to cover. I'm giving them names. These are, in some cases, industry names that are pretty common, but they'll help us have terms to think about. So I'm going to talk about provisioning of a project. I'm going to talk about the resolution of its requirements. I'm going to talk about the build step. That should sound familiar. And then packaging, which again, should sound pretty familiar. So your project interfaces with all of these domains, and I'll talk about them as we go. Your project provides particular bits of information as an interface into those domains. That's why it's important that you understand them. People get questions like, I get questions like, well, okay, I know I depend on G-test, but why do I have to put in my project here, and then in the include statement, why can't you just figure it out for me? And the answer is, well, to some degree, maybe we could if we had certain kinds of standards, but given the way the world works now, we need to be able to explain in all these contexts what your requirements are. And that's because there are different domains that are being analyzed by different kinds of tools. So when your project provides little bits of information in the YAML file, JSON file, and your source files, you're actually communicating to these kinds of tools in that domain, right? So the provision, the domain that provides things is what goes around the world, your code base, your, use Git operations, things like that, curl operations to download perhaps. It goes and gets things and brings them to you and provides an environment. So that's the object of that verb is environment. Like, where are you when you're building? Like, did you get everything you needed? Is it all here? Is it match what you expect? That sort of thing. That includes things like, are the versions correct? The resolve step is to take those files on disk or something, some approximation of that, and come up with a more abstract model of what your dependencies are logically. I call that the solution. I don't think there's actually good wording for this. This is part of the point of giving these talks, is to help us think about words for these things. But the idea that you have an abstract, a library, an abstract, an executable, an abstract, a code generation step, perhaps. These are all things that your build system might do for you, but you don't think about them in terms of like .a's per se or .lib files per se. When you're talking to your colleagues, you're talking about Google test. You mean the library Google test. You don't necessarily mean the package. There may be a different package in different environments. You don't necessarily mean the repo. You just mean an abstract notion of Google test, right? Such that you include the headers that works. You know what I mean? Like if you're talking to your colleagues. I have a dependency on Google test. That's what you're talking about. That's the abstract Google test. And then the third domain would be something very concrete for your build system. That is the literal files. So it'd be your files that include gtest.h and then have assertions or something like that. These are all interesting domains. They all feed into one another. You usually go from left to right on this diagram. You provide an environment, it gets resolved to more abstract requirements, and then turned into more concrete requirements. And we have tools that actually that help you along through these domains. So like tools like your package manager takes you from creates an environment for you. Your Docker file, your package manager provides an environment for you, and that sets up your CMake perhaps to model your build requirements in a more abstract way, and then your CMake can transition you into maybe a Ninja build script that can take the exact file timestamps and that sort of thing to give you the incremental build workflow that you love, such that you touch exactly one file and only the things that need to change get built. And that's what this looks like, right? So we provide the build environment through like a Docker file, for example. Then that environment is an input into the resolve step that provides an abstract solution. That would be what CMake models when it does the configure step. And then it goes into a build action, and then you get artifacts coming out. Intermediate artifacts, like perhaps like generated code, and then final artifacts that you actually ship. Maybe, again, in a Docker environment or a flat pack or whatever you ship in your company, right? Or your organization. And that's what this looks like. It's like, okay, well, I have a executable, but I actually need to release it in the way we release projects. That is another domain, basically. But if you're shipping a library, it's interesting because the package step is actually an input to someone else's provision step. So you just ship the library in a package, then another project comes along and they can find you. How do they find you? Well, the names all match up. So that answers that question. It's like, why do I have to put this in 3 or 4 different times? Well, you're specifying that contract to a tool. My project has this name for a package. My project has this name for an abstract library target. That my project has these header files that you can use. Include them, please, this way if you want to use them, if you want to include them in your C++ files. And your tools can keep up with you as long as we're very thoughtful about how we design these things. So there's a lot of transitive graph building. For the mathematicians in the audience, or at least the math enthusiasts, that's kind of key. It's kind of neat. Like we have this directed acyclic graph of environment requirements that gets transformed using different kinds of like almost functional programming style techniques into this other graph that has more nodes and slightly different edges. And that gets transformed yet again into another graph that has even more nodes and even more slightly different edges. And that's kind of neat, but it works because we have these kinds of interfaces designed that such that the tools can work. And a lot of times when these tools break down, and these are points for home, when these tools break down, a lot of times it's because we, the engineers, have been imprecise about how these things work. When someone says, I can't find gtest.h, what does it mean? One of these things wasn't wired up right, is usually the answer. And how do you explain that? Well, it's kind of hard, right? Or if it says, unresolved symbol, something, something, I don't know, CXX35, it looks like it's a standard library thing. Well, yeah, something here. And in that case, maybe in the environment, you didn't pick like the correct standard library version in your environment or something. But how would you know that? And like you could go find someone like me that just hasn't seen enough of these that we could just tell you. But if we get these principles right, we will stop having to ask those questions. We can inform the tools better. They can give you real error messages saying like, hey, you need these version ranges of these environments. We're just going to stop because you don't have it. That's what we want. We've been asking for it for a long time. If you look at the polls for like C++ in particular, people want like package management, they want dependency resolution, they want CMake that doesn't stink, right? And but what we need is to own some of these problems, at least to the extent that they're ours. And that's what I'm trying to help us think about better. So let's talk about nodes. The identities of these nodes are very key in these processes. And I've been already getting at that a bit, right? When you say in the provision step, what are we looking at for identities? We're looking for like the package that ships the CMake tool. We're looking for the package that ships the Google test library. They're specific names. Just like we have variables with specific names, just like we have header files with specific names, we have to be specific about it so that everyone gets what they want. The same thing with the resolution step. We might see a CMake target name. If you've seen, and this is the beam and exemplar target names, for example. So beam and : exemplar is the defined interface for if you're going to depend on beam and exemplar in a CMake lists. And if you've ever used VC package, for example, they're very good about that actually. If you download a VC package, it'll say, use this find package command and then use this target name in your CMake list and everything should build fine. But we could be more rigorous about that and make standards around that space. And I'm working in that kind of area. But in the meantime, it's up to us to like define this better. And again, for build steps, it's a little more straightforward. Oh yeah, that's the CMake command. I've used that from the command line, right? Or that's a header file, I can tell. There are other interfaces I didn't cover here, just to be clear. That's not the extent of it. There are other ones, but they also need similar amounts of thought. Like symbol tables, like aren't exactly, none of these aren't necessarily directed acyclic graphs in the same way. That's why I covered that previous one, is because they actually have more interesting modeling challenges. But they also have identities, they also have interfaces. There's also like a design by contract thing you can think about with each of these for things like, am I using licenses that are not suitable for my project? Or do I have any security bugs according to this list and this requirement for my customers? That kind of thing. Or even file systems. Will my project utterly fail if I go into a case-insensitive file system? Has anyone had that problem before? Yeah, guess what? We had this problem in the Beeman project. So like these things come up and it's like, that's actually an interface. Like, oh, if you're on a case-insensitive file system, I need to design my project such that it works fine on a case-insensitive file system, right? And ideally test it, again, with the CI system. When you change, it's okay to change some of these interfaces. Sometimes we get the wrong choice. That's fine. Just like any code change, use the same principles. Provide an opt-in solution that's compatible with the current solution, to communicate with your users really well about what's going on, why, how it's helpful for everybody if they make the change. Talk about timing, how soon or late is this change required? And eventually, hopefully, remove the legacy thing that you don't wish people weren't using anymore. So we use the same techniques. Again, this is a mistake I see sometimes, is people just like, oh, they just add a new option, a mandatory option to their CMake project or something, and they didn't tell anybody. So all the builds just broke, all the CI just broke, and it's like, well, you didn't tell anyone that was a new option, you didn't make it opt-in first, you didn't warn people that they didn't provide it, and so you were not communicating a change in the contract the way we need to. Okay, so that's all the theory. We're done with that. Hopefully everyone kept up. This is a good time for questions if anyone didn't. All right. Okay. We can get more in the Q&A if anyone has more to talk about later. This is going to be a lot more pragmatic. Right? So I'm going to talk about specific mistakes. Okay. So one easy one. Let's start with an easy one that hopefully we all agree with. But if you don't, speak up. We can talk about it. Unclear project contracts. So I've been talking about design by contract. Let's keep with that metaphor. I've had this question. Have you ever had this question? Like, is this a real project? Is this a production code? What is this for? Is it like the other thing? Is it like that other thing? It sounds like the other thing. Is it the same thing or is it different? Right? Or has anyone had this? Yes, you have. Does it build this way? How do I build this? Right? So instead of that, just get ahead of the questions. Put them in your README. Right? Like it's not crazy. In fact, the thing you all can do going home, going back to your open source projects, is just insist on this kind of thing. It's not a big ask. Like just write it down, please. Like, hey, look, I'm glad you added that new test, new set of tests. Let's go ahead and throw that in the README so everyone knows how to use it, right? I think that's a completely fair, red X on the pull requests. I'm like, yeah, I'm love the merges. Just get that test documented. That'd be great. So, that includes also contributing guides. That's an interface that's very important for a lot of good projects. Is like, do you want change? Do you want pull requests? Is it that kind of project? Look, if you don't want to add a build system, fine. Just tell people this is just my toy project. Go away. That's fine. Did you have a question or? Okay, he's a great. I think thumbs up over here. Sounds good. I'd love more standards in this space. Eventually, hopefully we'll have those. But in the meantime, READMEs, please. Lots of them. Mistake, inconsistent or claimed project name. Now, we just talked about a node identity, so maybe this is kind of points for like, okay, how do we apply that? Well, what problems do we see? Like there's a vague short name that probably someone else has. There are 5 or 20 projects with the same name. We see this in linear algebra projects a lot. Like maybe some of you worked in that space. Or just someone's just not thoughtful enough and they stomp on a normal project name. By the way, like the UV project, both of them are fantastic and they have the exact same name. It's just unfortunate, right? This is also in the space is incomplete forking. What do I mean by that? Well, if you fork another project, but you didn't change the identities of all the nodes. So now guess what? Now you have a node conflict and those nice tools that transform from the one directed graph to the next directed graph, all of a sudden there's a snag and all the nodes fall on top of each other and the end user gets a weird build error, or worse, undefined behavior in production, which is a form of safety violation, right? Ad hoc vendoring, what do I mean by that? That would be, copying someone else's code into your project. You have to be very thoughtful about how that works. Lots of people have requirements about where code comes from and they can control it more. That's an interface that's important to them. And if you come in and just copy, I just copy G-test in my project. Like, well, I copy G-test into my project too. So which G-test are we using when we link? Well, it depends what the linker did, right? And the linker doesn't know anything about G-test. It just knows about symbols, right? And then, yeah, if you're changing the name of your project, that's roughly equivalent to a forking. So again, that's a changing contract, as we talked about before. Communicate with your users, make the transition, warn them automatically if you can, that sort of thing. So instead, come on, let's just do some homework, right? So looking for exemplar, for example, let's go to this example. What do you see in different contexts for the exemplar project? And you don't see much. In fact, I looked in a lot of places, you don't see it pretty much anywhere. There might have been 1 or 2 package managers where I searched, and there were other projects that were exemplars, but they weren't the Beeman exemplar. That was definitely a unique name. So we can be very confident as new project creators that we're not going to be putting our users up for failure in that case. And again, that's really important because, especially for libraries where things link together, regardless of the language, your end users have big problems if one symbol comes from one path of dependencies, one symbol comes from another path of dependencies, and now they just can't link. And sometimes it's out of their control because their dependencies are making decisions about whether those things even are coming into the same link at the same time, right? So do your homework, get ahead of this problem. This is the hardest thing to fix. So definitely try to pick very unique names, 3-character names, problem, vague names like util. You're just more likely to have collisions. So pick up those you can always make up those nonsense names like they do for drugs, at least in the US, like proveritol. Like that's not a real word. Perfect. No one will get that one. Yeah, and I even search some other languages just to be safe. We don't want any Python packages collisions, don't want any cargo collisions. Yeah, we got some hits, but nothing concerning. Mistake, neglecting library file names. This is actually interesting because we have, let's just look at the examples in detail, I guess. So for, what do I mean by a library file name? Well, I mean like the name of the .lib file or .so file or the .a file, that sort of thing. Stop me if you don't know what I'm talking about, but just the files that you physically ship. They're binary, bit compiled things. Maybe your project says, well, everyone should just be building from source, so it doesn't matter. But it's unfortunate that if that's where you stop, because this is actually an interface used by other ecosystems. It is very common in the way that code goes from the solution model to the build model to try to use flags like this, where it says, well, I have a search path, it is the priority search path, and then I'm going to use a fragment of the file name to actually force the link to happen. And when that happens, you have an ambiguity, because what if something else is also on the search path that has the same name? So you have a cool library, it's named libutil.a. Does anyone else in the world have a libutil.a? Right? Oh, well, hopefully not. But how do you know? Well, you don't. So pick something pick something, again, use your package name, maybe in the name of your library file name, right? It's worth noting that header-only libraries kind of claim the library file names that come with them. So if you're shipping a header-only library, you're kind of like, and you name it the foobar library, that means if anyone else is linking a libfoobar.a, what would you think? If you linked to libfoobar.a, you'd be like, wait, I thought that was a header-only library. What am I linking? Well, if it came from some other library, now you're just confused. Your AI would be confused if you used that. Everyone would be confused. So let's just not be confusing, right? So ideally, name your library files after your project. That's not too complicated. Again, but that's an easy thing to put a red X on the PR. Hey, I noticed when I built your thing, it shipped a libutil.a. Can we go ahead and use the project name in that, that little bit of your CMake that mattered, right? So these are all reasonably unique. Like these are not ambiguous statements to make. By the way, ideally your build system would use the last item in this bullet list, just a fully qualified path, clear to everybody exactly where that is on disk. But some things don't work that way. And again, case insensitive, right? This one's interesting. Your users, the people that want to use your project, have build systems. So that's a reality we're going to have to deal with. We reference your project, whatever it is, even if it's a pile of headers or something, in our project. So how do we do that? If the answer is, oh, it's easy, just add -i, vague user include your path, that's my project. Well, is it your project or is it like a lot of projects? I want to talk about your project. And if you haven't defined an interface for that, they don't have a way to express the dependency they need. There's nothing in the solution model to model your project. Why is that a problem? Well, it means if somebody else also depends on your project and you both have version requirements, there's nothing in that graph to help them identify those kinds of problems. There's certain kinds of transformations that the tools want to make mathematically where they have an incomplete graph to work with. So you're going to end up with bad answers. You're going to end up with poor user experience for your users. So we're not asking for a lot, right? But what we need is you as an owner of a project to define some of these identities for yourself. And don't worry, I'll walk through some concrete examples. And again, if you just pick an obvious enough project name, most of these things take care of themselves. But this is what it might look like. So and again, I mentioned like VC package is pretty good at this, for example. If you have a dependency in your build system, this is how you're going to reference it. This is the target name. And it comes from this file, right? You might say, if you're using, let's see. Yeah, so we have so I have a CMake example, and then right below that, there's a package config is a very common interop standard for cross-project dependencies. It also has identities and like files that reference those identities. If you're using CMake, when you're exporting your target, whether that's a bunch of headers or whether it's a fully built library, you can use namespaces. That's really helpful. And you could look for the documents of the install command in the export section to see how this works. Again, you can go to the Beam and Exemplar project to see how we do it, if that's more your speed. If you don't use CMake, consider shipping some of these things anyway. CMake is definitely the plurality, if not the majority of projects out there. It might be a pain to you that you'd have to even think about CMake. And if it is, let's get to the end of my slides and I'll tell you where we're hoping to go with this. But you could help drive some convergence in this. There's a community that I'm in, that I participate in, where we try to talk about these kinds of concerns, come up with easier ways to support all these things. Hopefully one of these days we'll end up with just put a JSON file in your project workflow that we all expect. In the meantime, this is the job requirement. Another mistake is unconsidered header identity. This is really common. I've seen a lot of people get burned on this a lot. Like a new engineer is just trying to get things to work. They get something to work, but they get it to work in the wrong way. You can do that in C++, but guess what? You could also do it in other parts of your code base. For example, these are all valid references to a header file. For some definition of valid. Some are more, but all of them are problematic in different ways. So the first one is just, the file, if you just did an ls in like your package, what files are in there? Okay, that's the header file that comes with Beam and Exemplar. Okay, fine. But below it is one way to include it. And below that is another way to include that. And depending on how you write your build system, depending on how you write your C++ code, they could both work. Like you would get a fully functional program, no bugs, like the tests all pass, but one of them is good and one of them is not good, right? So the one that's not good is the one that is identity.hpp. That's a pretty vague name. It's high likelihood there's another one out there. And again, in the graphs and the nodes, when you start, collating things, there's more than one thing that is, let's say, config.h. Has anyone seen one of those before? Yeah. So with better, let's go ahead and namespace our stuff. So instead of config.h, beam an exemplar config.h. Oh, I know exactly which one you're talking about. So we're just being clear. This is the node I need. I need that header file to be a dependency of this source file, very specifically, right? And not the other ones, right? So watch out for, again, config.h. Watch out for core/util.h, that kind of thing. You're better off putting out, it's a little more typing, but it's worth it because it makes everyone else's life that much easier. And again, AI agents or whatever, they don't have to go read all the code and figure out what your build system's doing in order to figure out, oh yeah, I know exactly, there's only one of those. I can find that. I can go look at that if I want to. Same thing for your static analysis tools, for that matter. Much less fiddling around and figuring out why the wrong config.h showed up in your static analysis pass. It's not ambiguous about if it's missing or not or why, right? Important point, the second top level bullet point here. Be sure that when you have one of these header identities defined, use it for yourself inside of your source repo. That keeps it easy for everybody. Like whether you're building your own code in a developer mode, or whether someone's building against you later, like out of a package or in a monorepo or something like that, if everyone uses the same include target, then that identity carries in both of those contexts. We don't have to have another mapping step defined somewhere to say, yeah, in dev it's this, but if you ship it, it's that. And that sounds like an exotic use case. It's not. It's very common for people to use like a ... thing or something like that. And that only works if it was installed the same way that it happened to be in your source directory. So the easy thing to do is just basically have an include an analogous include directory in your source repo and just install, just file by file, same directory structure, put that in your package, or map that into your monorepo sandboxing build environment or something like that. So I highly recommend that. And be consistent in your code base. Don't sometimes include ... /identity.hpp and other times include the other thing. Again, it's really good for your users. It's good for your tools. Let's be consistent. This one's a little more controversial maybe. But this is not a problem in Java. How do you know if it's a Java file? It's got a .java extension, right? How do you know if it's a Python file? .py file. How do you know if it's a C++ file? I mean, really think about it. How would you, as an engineer, write a tool that tells you if it's a C++ file? I mean, the only canonical thing is go ask the build system, did you pass it to the C++ compiler or with the C++ flags? That's literally it. So to answer that question, you have to provision an environment, you have to configure you have to solve a solution, and then you have to run a build, and then you can answer the question. Well, guess what all the other languages do? .ext and whatever API they're working on, right? That's ridiculous. So we can help. Like I can't tell you there's a standard for this, but we could do better. Let's just all in this room agree, everyone online watching the video, let's do better than that, right? It's really bad, actually. So why do we care though? Why do people like, it doesn't matter, what doesn't matter? But it does matter, right? Guess what? People write heuristics to figure out if it's C++ so they can syntax highlight your code. How much better would it be? Oh, it's it's one of those C++ extensions. I got it covered. It's fine, right? That's silly. We don't need the world to be more complicated. It's already complicated enough. You go to GitHub and you ask, is this .h file? Is it C or C++? And they'll say it's C/C++. Who writes C/C++ authors in the room? How many of those? Anyone want to raise their hands? Yeah, we got a couple. But that's one of the things people gripe about, right? Oh, I don't write C. That's not a real language. Oh, I've seen your header files. It is a real language. You ship the same header into your C code and into your C++ code. So guess why it's ambiguous? That same file is compiled with a C compiler and with a C++ compiler. So if it's only for C++, pick an only C++ file extension, nobody has to wonder. And then you can be really proud about it is exactly C++ and not C. So here's some ideas. The Beeman project settled on the .hpp and the .cpp file extension from this list. Why? We actually did a quick survey, just got some data. It was a plurality of uses at least, if not a majority. So not the most important thing to think about, so we just went with that. But if your code base you like .cc or .hh, I'm not going to complain. At least make it clear, please. It'd be nice to have a standard in this context. It would not be nice to debate all the things in order to get to a standard in this context, so don't expect it. But have a standard in your organization, be consistent, but mostly be unambiguous about the language. If you do have a file that is supposed to be parsed as C and as part of C++, that's actually harder than it sounds. I guess maybe pick a new file extension than .h just to be clear that you're doing it on purpose. It would be my recommendation. Mistakes, no correctness contracts. Useful, okay, so you've written the perfect piece of code, I know. You don't have any bugs, I know you don't have any bugs, but someone else needs to patch your code sometimes. They're porting it to the new OS, they're porting it to the new compiler. They want to use C++26. There's new stuff coming out. So they're gonna need to change your code. They need to know, does it work before they make the change? Does it work after they make the change? That sort of thing. Your package maintainers are moving, again, like it might not even be someone in your organization, might not even be someone that's met you before, is going to need to make some of these changes and figure things out. It might be yourself in 6 months looking at the code thinking, who the hell wrote this code? I've been there. And you're like, does it work? Right? The good news is, good and bad news is, modern build systems have standard test hooks. And even then, people ask this question, right? So, okay, so spoiler alert, right? Like, oh, surprise, rate tests. You want some accurate tests, you want reliable tests, because people need that closed feedback loop. They need to be able to say, yes, it worked before, and it's not fuzzy or unsure. Not some passing tests, some failing tests. Are those the important failing tests? At least get the core stuff that really is really reliable and hone in on those, and then work to add more things to that space. Define the contracts, define the test workflow, define which tests are used for what purposes if you need to, and which environments. Again, really help your users, help yourself in the future. And at a certain scale for packaging systems, we need this. If we really want packaging in our ecosystem, we're going to need that kind of thing where people can say, I took your package, I put it in this new package manager, or I upgraded our ecosystem to the new C++ version, where it works with the new Clang version. And you don't want it to be you, I promise. You have enough tickets in your backlog, I'm sure. So this is how you keep tickets out of your backlog. It's less work to do this on the whole. Mistake, a little no build support. I see this actually a lot more than we should. A lot of people think, I got a bunch of header files, they're great, just take them. And like, what's your test for that? How do I build so I can run your tests? Do your header files, you work with the new compiler, that sort of thing? I'll take what I can get. I mean, at least if you have a README saying, I promise like all these things work and all these things don't, at least I know where to approach that project. Probably I'm not gonna package it or use it, but at least I know where it is and other people can work with it too. And I put it as a risky kind of category in this is if you have a bespoke build system, not because, look, your build system's perfect. I'm sure you wrote it from your grandmother knitted it from yarn and it's fantastic and it's very personal to you and I get it. But odds are it really doesn't have all the features that somebody needs for their environment. Like I'm talking about features that are usually on the low on the list of the feature enhancement requests that you never quite get to, even though you meant to. Things like, does it have coverage analysis? Does it support the new sanitizers? Can I run the static analysis tool easily? Can I just fire up VS Code and play around with your project? And the more custom your build system is, the less likely that you have these boxes checked, and the more likely that it's in your bucket, which is already too full, to deal with these kinds of problems, right? So instead, have a build system. Pick one that supports a lot of features. Writing a build system is a big mistake for the most part. It's hard. So like pick something that really has the feature list. If you don't have an opinion, or if you don't want to like solve the world through better build systems, just use CMake. It's not super complicated. Bazel's fine. Like there's lots of options, but pick something, stick with it, use it. Don't just give me a pile of header files in particular, right? Have tests, have a build step, have an install step so I can package your header files the right way, so I can clarify how to include them and how not to include them, that kind of stuff. If you're wanting to disrupt this space, look, it's hard, but at some point it's going to happen. I'm sure we're not going to be using CMake once the apes have taken over the planet and the head of the Statue of Liberty is laying in the sand outside. I'm sure there'll be another build system by that point. So by like, the mean value theorem where, somewhere there's going to be a better build system, right? Mistake. This is actually super common too, over-specifying build rules. It really hurts the portability of your projects. And again, like we're talking about interfaces, what are we talking about? Well, if your interface says, I have this flexibility in the environment, if you have to be too narrow on that flexibility, then you have to get a lot of little build instructions for all the possible scenarios. And you really want to avoid that. You want a nice abstract, here's how it builds statement, where you have kind of a polymorphic thing for the environment, right? So the more specific you get in your build rules, the more you have to write spaghetti code to adapt that interface to all the different concrete applications of that workflow. Hopefully this rhymes with things you're thinking about in your code, right? So things that count as over specifying your build rules for let's just go with the slide bullet points. So many choices must be made before environment provisioning. Something that knows it's going to be building an executable eventually walks backwards from that step. This is a fundamental law of programming. You start with, I'm going to build an executable. What are my requirements? That is like, what's the environment for? What are the transitive dependencies? What versions of transitive dependencies work together? Your tools do this for you. A lot of them do, hopefully really well. But these choices are made before environment provisioning, very important, right? What's your C++ standard version for that final link, okay? So think about it. If every library that is linked together, each tries to set this value specifically, then they all have to get it exactly right, or you get mismatching symbols, you get one definition rule errors, you get memory corruption, you get to use all of Greg Law's fantastic tools to figure out that you just messed up the build system, right? Which is one of the hardest things to debug in my experience. It's because it doesn't even show up in your GDB window. It's just like, that's weird. I must have built it wrong. The thing's jumping around funny, right? Well, it wasn't jumping around funny. You're looking at this header, but the symbols from that library, like they didn't match, that kind of stuff. So sanitizer enablement is actually really interesting in this space. We're very concerned about safety in C++ ecosystem. Some sanitizers, you need every single library to be built with that instrumentation turned on. So if every single project is individually hard coding the flags to get that sanitizer turned on, what are the odds that when you have a dozen, 2 dozen, 300 dependencies that they all set the flags the right way? The risk grows and grows exponentially, right? So that's a mistake. That is over-specifying the build rules when you need to go per project to set these things. What do we want to do? Well, hopefully you're coming to conclusions already, but that's just a bad interface for that everyone needs to match perfectly. This would be bad code. If you saw the C++ code, you'd say, oh, like everyone has to call the enum with the same flag or else you leak memory or something. That's horrible. Why would you do that? Well, let's not do that for project code either, right? So many choices are workflow specific even, whether you're debugging or not. Maybe it's not something you need to know before you provision, but you definitely need, like whether you're doing this or that is where you make those choices. And again, how would every library know what the user is trying to do? And also, I mentioned Hiram's law, the idea that any observable effect of a program or a project eventually becomes relied upon as an interface by somebody somewhere, the more users you have, right? And so all these little bits and fiddles that you add to your project are things that eventually someone will observe and rely on, and then it will become an interface, whether you meant it to be or not. So mistaken over-specifying build rules. Let's get them a little more specific, maybe a little more tangible. Maybe you've seen these things before. If you open up a CMake list.txt and you see manipulation of these variables, CMake underscore something, especially CXX flags, toolchain files, C++ standards, that's something to really watch out for. These are all things that, again, the thing that knows it's linking an executable needs to define that for everybody and somehow inject that into your build so it can help you match everybody else. So if you're setting those by hand, how do you know that the injection worked? There's possibly ways to do that, but it's something you're going to have to wrestle with, and you can't just throw it in there and expect it to work. So the Beaming project exemplar and the other Beaming project repos specifically don't set the C++ standard, which is frustrating to some people because they just want a button that just works, although we did provide that button, as I showed you earlier. But it's confusing, like, oh, but I'm a C++ 20 project. And the answer is, well, except if you have an executable building against you with C++ 26, then you're a C++ 26 project, aren't you? And how do you know? The answer is you don't, so don't. So fiddling with build types and CMake list.txt, that happens too. Like, am I a debug build? Then these flags. Okay, wait, why your project? Why only your project needs to set those flags? What's special about your project in the whole world of projects, all the thousands of projects in the world, that you have different debug flags than the other things linking into the executable downstream, right? Mentioning specific flags in your CMake list.txt in general is actually a caution flag for me. Like any dash whatever. Like, because what are you doing? Why are you the only project that needs to do that? Is there a way to reuse that code? We wouldn't accept that in our C or C++ code. We would say, oh, that needs to be an algorithm that you reuse across all these different situations when you're fiddling with the bit shift operator or the pipe operator or something like that. That's not normal code we write here. We would like you to use the serialization API, or we would like you to use the graph algorithms API or something like that. So when we need to do more in our build systems and say, that's a smell, I'm at least gonna make a comment and say, I don't like that this is in here. I'm gonna make an issue to go follow up with it. But this is not something I would like in my code. And you have to think twice about, do I want to merge it or not, right? So thankfully, CMake provides ways for you to actually ship code from one project to another project if you need to, so you can reuse CMake code between projects. I gave a talk back in 2019 about this called Modern CMake Modules. And so CMake actually has ways to effectively define libraries for CMake that you can use across projects. So that's a really effective technique there, by the way. So instead, use higher level contexts. Invest in dependency management tools. So a lot of these if statements are around, like whether you're in this context, this dependency, that dependency. Let them like communicate down to you what the high level requirements are. So more concretely, like VC package has something called target triplet files where it's going to tell you a lot of these flags for you. Conan has something called profiles. Maybe any Conan users might recognize that word. You can actually set the C++ standard in the profile. Monorepo build systems already know how to plumb around CXX flags and things like that. So like if you just use those the way they're designed, you're fine. And in fact, your project gets simpler and you're more accurate to the final link. It's like win-win-win. Less code, works better. You don't have to think so much. It's perfect. The CMake toolchain files in particular for CMake users are a very effective tool for this. If you're defining your environment requirements, that's what they're for. So like, where's your compiler? Like fundamental build flags, are you optimizing a lot, a little? In fact, in my day job at Bloomberg, we use those also to ship the other more developer workflow type choices. Which do you want, the really fast experimental linker? Do you want to use the distributed caching system? Do you want to, what's another good example? Oh, do you want to use sanitizers? We all do that through toolchain files. In fact, all of VC package is implemented basically as a toolchain file. So it's a very powerful mechanism. Beware, there's a lot of things to learn if you want to really get into it, but the basics are fairly simple. It's just set those flags we just talked about in a file and pass it in as a special name. It's actually really nice. Bloomberg uses this so much that we actually went upstream into CMake and said, hey, could we have some more environment variables? It's just a lot nicer in certain contexts to set CMake toolchain file as an environment variable, maybe in your dot files, and then so you don't have to keep typing it everywhere you want to build or something like that. So there's a lot of things like that that can help a lot if we take some time and work with our open source partners and stuff. We do need some more work in this. If you're interested, again, join in the ecosystem standard community with me, and we can talk about what we can do in this space. There actually is a model here that is some nice convergence from different directions, but nobody's bothered to sit down and make a full interop standard for this, which is exactly what I was describing. Like, how do you describe your build environment, the OS, the required flags, that kind of stuff. Another mistake is a kind of a more specific application of that is treating your warnings as errors unconditionally. I get it. Like, I understand, like you want no bugs in your system. I also want no bugs in my system. But you have to think, let's think about this contractually, right? So let's say you're setting warnings or errors and you're aggressive. You like the extra flag, for example, right? I want extra flag, not just the all warnings. I want more than all, because that's a thing. I want the extra, right? And so what do those do? Well, they're like a little less reliable, a little more picky, but maybe that's your style, right? And so you set both of those flags. What does that mean? What's the contract? Well, those mean unconditionally, regardless of whatever version of whatever toolchain you're using, I want that set of static analysis tools, and I want them to always be in error. So you're supporting that? And you might say yes. I'm like, so you tried that with GCC 16 already? And if you said yes, you're a liar because it's not out yet. So you're saying you don't want a project that's portable to GC16. Like, well, I mean, I want you to fix all the warnings every time you want to go to GC16 is what I say. Okay, I get that for your project, for your test environment. That makes a ton of sense. But you want all the people that possibly want to use your package in that context to do that? Like individually, they're all going to carry their own patches for your warnings until eventually they update to the version that you provide those patches with. That's not a good workflow. And more importantly, your contract is poorly specified in that case. You should just say, never ever build my project with GC16 until I let you. And then but that seems like an unreasonable thing to say. So probably what you really meant to say was something more precise. Warnings and errors, but only if you're within these version range of GCC or something like that. I guess it's defensible, but it's not a nice thing to write in your build system for the most part. Probably what you'd like just as much, if not better, is work with the build system. Again, pick a good build system. Work with a build system that understands that there's different workflows where warnings are interesting and they're used different ways, right? So if you're developing locally, you want to see the warnings right away because you just wrote a new piece of code. That code should be pristine. You want to see the warnings right now. Stop everything. Let me fix the warning, perhaps. But if you're doing a packaging workflow, the interesting thing might be, okay, let's just ship this thing. And then we're going to go ahead and make a bug report against that project because we have new static analysis issues. So I can ship and fix bugs in parallel, both work streams, and we can do both at the same time. So those are different workflows. So have a build system that knows how to do that. And if you hard code W error, W extra, W all, those kinds of grab bag things, you get in the way of that. You're telling the users they can't have that workflow. You cannot asynchronously fix bugs while shipping at the same time. Because they're not new bugs, by the way. They're good things. Like you can find your compiler upgrade is telling you, hey, I found new bugs you can fix. That's good news, but you're telling people you make the good news into bad news because it's like, hey, I found new bugs, but also you can't upgrade your compiler. Like, well, that's great. So good news, again, Bloomberg's partner has had this issue. We identified this modeling issue. We worked with CMake upstream. There are new features in CMake in the last 2 to 3 years. It should be easy for you to get a version that works with this, where you can say to CMake, I want, by default, warnings as errors on my code base. But you can also say to CMake, but I'm packaging, so for now, just return 0 in those cases, and I'm going to go ahead and ship that. So you can, in your CMake, express exactly what we're talking about here. You can say, like, depending on the workflow, I have more power as a user building about whether I want the warnings on or off. And it's really nice. You can set it up with your IDE, your CI system, all those things. So the defaults are different depending on context, which is exactly the lever we want. Right. So if you want to be more specific, sometimes that's fine. Like if you want to say like W error, a specific error, that's usually, again, that's a more precise contract. That's not as big a deal. But if you are setting things hard coded, they actually need to match your compiler version and not just your compiler identifier, like the toolchain series. So that's probably why this is fiddly. So that's, again, why it's good in a toolchain file or in a command line argument a lot more better than it is inside your CMake lists. All right. Okay, well, those are just some principles. I went through a bunch. There's a bunch more. Like we could have more and more talks about this for a long time, but I don't want to bore you, of course. So these were all just illustrative for y'all to think about. Like you might be like, oh, I didn't even think. Like, oh, that is a design problem. Like that I'm hard coding flags. I thought that was just a big bunch of spaghetti code that nobody cared, but it actually does. It affects people. But a lot of you are like, okay, those are principles, but what do I actually do, Bret? Like, I need to write code. I need to look at something. So it's really common for people to ask me, well, show me what you're doing, and then maybe I can extrapolate from there. So this is what I'm doing. The Beam and Exemplar project I already mentioned. Let's talk about it a bit. We have a nice logo, so you know it's a real project. But it is open source. It is a very permissive license intentionally. Ideally, some of these projects would be used in like maybe exactly the code, or at least heavily inspired code would show up in your standard library at some point, C++ 26, C++ 29, 32, that sort of thing. There's a website, there's a discourse. If you want to jump in and talk about things, just jump in the community, try things out, tell us what we can do better, like suggest things, that sort of thing. We're in GitHub, so we use normal open source workflows, so it's not some rarefied, I need to travel to Sofia, Bulgaria to have a conversation about this environment. You just come in and say, hey, I have an idea, or hey, I was looking at your idea and I was trying it out here and then this happened, that kind of thing. It's a collection of engineers, so it's a community, but it also has a bunch of libraries that you can use and try out and help us develop. If you're a library developer, hey, cool, open source project, C++, a lot of people want to see, you see these on forums. Hey, what's a cool C++ project I can jump in on? Hey, guess what? We got a bunch. Try them out. Come and contribute to some. It is also providing a clear path towards standardization for library development. So if it's targeting that specifically. So if you're interested in saying, hey, I got a great concept that should just be a standard thing that everyone not just has access to, but comes baked in with C++, this is maybe for you, right? So there's a fundamental algorithm that's been missing this whole time. There's a thing that should have been standard 10 years ago. Fine, let's do some open source work and get that going. So it's for those workflows. It's very holistic, includes paper process and ISO. People team up on that, and includes open source work, includes writing tests, includes writing docs, like a full service library development and open source. For the C++ community, if you're interested, you want to get early, try things out earlier. The papers that are maintained in the Beaman project, again, are just code. And we're working towards packaging them. We're working toward, they should already be useful for fetch content workflows in particular. But more contributions welcome in that space. Try them out, file bug reports before even people start arguing about whether they fit in or not, or in which shape you can get in there, right? It's worth noting they're not necessarily maintained to be stable. So, and there is a model for how to describe how stable an interface is in the Beaman project. Again, that's a contract specification. So a lot of them are fairly on the unstable side of things, especially for C++ code. But that's because if it goes through the standardization process and all the names get changed around and the parameters are different, which is pretty normal, we don't want anyone to be too surprised by that. So we just want people to be aware, like, okay, well, if the paper gets revved, then yeah, you're gonna have to rev your code, give or take. So we could talk about it in more detail if anyone's interested in that. If you want the URL, here's a QR code. This is the URL for the Beaman exemplar project that I've been referencing. This is not going to get standardized. This is the only project that's not, intentionally not, but it exists to support the other projects. So we want it to be nice and easy for library authors to come in with a great idea, write a few header files, write some test files, and mostly just not worry about the rest of it. And this is where we're innovating in that space. I'm driving consensus, coming to like, okay, what's the nice, tidy CMake we can come up with, and that sort of thing. The principles I'm talking about here, we discuss in our pull requests, in our Zoom calls, in our discourse threads. We talk about these principles. Like, well, is that a thing we want to do in every single Beaman project? We talk about that kind of thing. Well, so maybe the flag doesn't go there. Maybe we can put it in this other place we can reuse, that sort of thing. So what is it exactly? It's kind of, it's a trivial example, which is great for these kinds of things. It re-implements basically the stood identity type. If you're not familiar with that, it's most useful as maybe a default argument to different kinds of things that take some kind of a single value function-like object. So you might have a map or a reduce type workflow, and you want to have like what's the default thing that you should pass in? Well, maybe the thing that returns itself, right? Like it's a transformation of a thing to itself, right? Basically. So like maybe you're printing and optionally you let people like transform the value before it gets printed. Well, you might just say, well, the default is don't transform. That's what the identity transformation would be. That conforms to we have a standard that we're developing for the group. You might consider it for your projects, so open source at least, and maybe enterprise quality projects someday. You could extend it or something. Again, contributions welcome in that space as well. It's an example of a minimal modern project structure, because again, it's a pretty simple mechanism. So hopefully the only thing interesting in the repo is everything that is not the code to some degree. And the goal is to use industry standard tools and technologies. We're not trying to innovate here. You're not going to come into this project and say, wait, you invented a build system from scratch? Like, we're trying intentionally not to do any of that. We're trying to be boring as much as possible with all this tech. Simple, reliable, but real, shipped, tested, packaged. We're not here to like demonstrate all the possible bells and whistles of everything. There's a lot of project templates out there that do that, which is great. And that's like an educational practice. We're trying to be like, actually, this is useful engineering tool. We've defined these interfaces, right? I talked about names being really important. We have definitions for them. Some of these I'm making up because we haven't gotten that far in packaging, but there'll probably be something like this. So these are the names for the provisioning domain. We talked about the provisioning domain being how you go grab something that you rely on. So one of the top is the really common one. You're going to go grab the code from GitHub. Like, well, we defined that. You go to the exactly Beam and Exemplar project in github.com, not some fork, something else, whatever, right? If you want the VC package for it, we have a pull request up for that already. You might put that in your VC package.json file in your project that wants to use the Beam and Exemplar, and this is the value of the port file. The port, it's a port name. Yeah, that's what it's called. Again, we're working on Conan support. You might mention in your Conan file.py or Conan file.txt file, the Conan package, it'd be named like with like a period, beam.exemplar, that sort of thing. Fetch content's interesting. I think I have time to talk about that. I'll get that maybe at the end if you don't have if y'all don't want to talk about something else. But it is a provision step thing, CMake fetch content, because it goes and fetches content, right? Goes and gets something. That's a provisioning step. So it has an identity, and it's important for you all, if you want to support fetch content, to also have an identity for fetch content. It has a name in the API. That's a clue that you have to pick an identity. And we picked one. It's the same as the other one, so not surprising, but you have to pick it. And then, more packaging that you could do. This is the resolution domain. We've picked names for this, right? So like the CMake package, so like the thing you would pass into find package. Again, beam and dot exemplar. This is like, hey, Bret, these are all the same name over and over. You're like, yeah, isn't that great? The same thing for fetch content. Wait a second. Did I put that on the wrong slide? Was fetch content both? It actually kind of is. Well, we could talk about that in a minute. CMake target name, again, that's what you pass into your target link libraries when you're specifying I have a library to link against. We have names for that. CPS component, that's also new technology. We'll get to that in a second if we have time. But so if you're saying a requirement in that context, again, you have a name for that. It's a 1: form. That's new, but hopefully not too confusing. And then building. So this is like, okay, this is stuff we all go, take a breath. This is things I'm used to. Okay, well, this is how you include it with the pound include, but we're specific about that. Don't include identity.hpp, include beam and exemplar identity.hpp, right? So if you got a different -i flag that happens to make the other thing work, that's on you. That's not our contract, right? If we do something to move our packaging or our directory structure around in your build breaks, I'm sorry, like we didn't support whatever you were doing there, right? And then the C++ type names, again, matches everything else. So you can look at the C++ type and kind of intuit, the package is probably the exemplar package, and the library is probably exemplar library, and the type name is exemplar library identity. Great for us, great for AI type tools that want to like just plumb things together, great for automated tools that want to transform with simple mappings and stuff like that. That's nice and big, good. I took a swag at how big I needed to make it. I mentioned earlier in like one bullet point that like licensing is actually interesting, and it's getting more and more interesting in our industry, especially for safety and security conscious use cases. So go ahead and do that, and we do, especially if you're open source code. Just clarify what the license is for your code. It's not super complicated. Make a license file. There's a bunch of places online you can search for the options for you. Something else you could look at, and we do, which is arguably redundant but harmless, is you can actually add a comment, this SPDX license identifier, to every single file. That's an interface. So I thought it'd be interesting to demonstrate that. There's a lot of tools out there that look for this, and they could tell that that specific file has that specific license. It's just a quick little tag, but there's a handshake there. There's a precondition, an operation, and a postcondition for those tools. If they see one of those, they can say, oh, that source file is also one of those licensed files. Because a lot of us copy code around, and sometimes you have more than one license in the same repo and directory structure. When we are clear about these sorts of things, then they don't have to guess per directory and make up bad heuristics that are almost accurate but not quite, and that sort of thing. So this is something you can do quickly. Because we have those license specification files, if you go to the github.com repo, you will also see the view license button. That's why I pulled that up here as a screenshot pull out here. Under the about from the project, if you could see the one-liner, but if you go down, it'll say view license. That's a good indicator that you probably got this right. And that's one of those contracts that you can fulfill in partnership with like GitHub, the GitHub in particular for here, that, oh, you set this up properly. So GitHub can really tell that your license is this. If you hover over it, it'll say like Apache with exceptions v2 or something like that, right? No, LLVM license with exceptions, something like that. Anyway, the point is it's a permissive open source license, but that's a good indicator that you got it right. So there's a kind of a test going on here, although it doesn't yell at you if you got it wrong, at least not yet. We talked about warning enforcement. This is how we do it. This is not a CMake list.txt, importantly. We put it in our CI workflows, for example. So we want to make sure that warnings and errors are checked. They're very important to us that we don't have warnings and errors. Well, we put it in our automation scripts, not in our CMake lists. That means if you want to take our code and put it in your automation scripts with different settings that are important to you, you don't have to come and hack around our code base to make that work. You can just plug it in with your own settings, right? Turn on more error warnings, turn off fewer warnings, whatever is important to your workflow. It's pretty big, right? This is actually our CMake list.txt, at least an excerpt of it that's pretty relevant to this talk. There's not much more than this, frankly. This is the interesting part, for the most part, other than maybe how we wired up our tests. You can see our identifiers showing up. You can see we have a library. The first on line 3, that's the name. That is what determines the name of the file. Remember, I talked about that being a mistake to avoid. Well, we picked a name that was unique to that's named after a project, right? So we'll have a lib-daemon.exemplar.a and a static library on Linux, right? So that's line 3. Line 4, we create an alias. That's where we have the nice build system level interface for that, right? So if you're if you find package or package, or if you use like some kind of submodule fetch content workflow thing or something, you can always use that name. It'll always work. Even within the project, we also always use that name, like in our tests. And that's how you might express that in a CMake project. Target sources is we attach the identity.cpp file to that library build. If you notice the directory it's in Daemon exemplar. So the relative path to that is Daemon exemplar identity.cpp. That's a very unique file. We don't have to worry about confusion in it for anything. For that detail, it doesn't matter so much, but might as well be consistent. There's another new target sources file. This might be new to a lot of you. This is the new technology. Bloomberg's working with CMake upstream with Kitware to contribute this to the ecosystem to improve these modeling challenges. Target sources is new. So we're on the Beam.exemplar library that we talked about. We're going to attach a file set, okay, set of files. Hopefully not, we're following along. They're headers, okay? They're in the base directory of the include directory. So we talked about like inside your repo, maybe having an include directory that looks like the installed include directory. That's that, right? And then you could just list all the files. If you want a glob, you can pass the glob result in if you like that better. And these are all the files. So what's new about this is we're not saying target include directories, build environment, and then install environment, and then hoping you get that right. We're just telling CMake, hey, by the way, I have headers that goes with this library, which is great, because that's how we think, right? We think, this library comes with headers. We just said, hey, this library that comes with headers, CMake. And we described with the base dir and the file enumerations how they're included, actually. So make sure that the include directory is that include directory, and these are all the files that go with that include directory. It's a very precise definition, which is good, because it allows for better automation. That means later in this file, which I couldn't fit on the slide, I can just say install the library CMake, and guess what? That's it. You don't have to install headers or anything like that. It knows how to go from there. And it wires up to other technology I'll be talking about in a minute. And then among the features that you get with these kinds of new techniques is again, because we have a nice model, we can do nice things. So this is a new target property. Again, Bloomberg worked with Kitware and to add this to CMake upstream, called verify interface header sets. What is this? What it does is it parses your header files. So your header files parse. Isn't that fantastic? Maybe I'm the only one that cares, but like this whole time, did you know that we never actually parse header files? We only parse source files. So the only time you can tell if a header file works is in the context of one or more source files that included that header file. So there was a lot of bugs out there that are like, this header file is actually broken. Nobody noticed because it's only included per se, like it's only included after a pound included vector, and it never actually included vector for itself. And it's just a broken header file. And you would never notice unless you happen to include it without the vector being included before. And especially in code bases that have a lot of nice formatting rules, they might alphabetically sort or put the standard includes above or below the first party includes. So you may never ever notice. And then you're shipping actually broken code this whole time. So what this gives you is you actually can analyze with static analysis, or even there's a compile command. You can put it in your build rules for your CI. Boom, build me all the headers as if they were source files. And you'll get those bugs. You'll say, hey, look, you didn't include vector in your header. Awesome. So that's the kind of nice things we get if we design well. And there's more nice things we can get. Like we can get better CI, more boring in a good way CI, boring in a good way, vendor support and, for IDEs, lots of stuff like that. All right. Yep. Yeah, it'll support the installation of your header files. So you don't have to like separately install your header files. You just say install my library and it'll take it. So that's really nice. Yeah. It's also the interface we're going to be targeting for C++ module support. It rhymes with this. I've got 10 minutes left, so we're doing good. So it's like this, but instead of being headers, it's CXX modules. So if you've seen any recent talks about C++ module support going forward, it's using a very similar interface. Again, also sponsored by Bloomberg in partnership with Kitware. Preview CPS files. So this is interesting. So this is tech I've been working on in parallel to my work on the Beeman project, is coming up with better models, better practical tools for this. So you might have heard me in other contexts talking about C++ packaging and what kind of research I'm doing in this space. This is where the rubber hits the road. Because we have this, I can generate this. And what is this? It's a JSON file, right? So good, boring in a good way, yay, right? I could Python work with this, and probably your AI could kind of figure out what's going on a little bit, right? And it's basically describing in a portable way that other build systems can understand, whether they're CMake or not, what's coming with your library when they build it and install it and get from the provision step all the way to the package step, carries with it that kind of context. It's describing the contract for your project in a structure that plugs into other contexts, right? So it's actually an abstract representation of the solution node, if that makes sense, using what we were talking about today. It's describing your library per se. And this has been a big missing piece in the C++ ecosystem for so long. Everyone I talk to says, yeah, that sounds great. And then we're still filling out, like, what is a library? And like, do we have to parameterize anything, parameterize stuff here more or less, or how simple or complex can we get it? But this is where we are right now. It's in CMake 4.0 now, where CMake 4.0 is released. So if you want to check it out, you could turn on certain experimental flags and try it out too. That's what I did here with exactly this code. And then I added, a couple of little bits that are described in the docs for this feature in CMake. And this is what you get. It describes a library, a static library. That's what the archive value means in line. I guess it's line 3, but I guess didn't put line numbers on there. So components exemplar type, it's an archive. That means it's a static library. And that's in the exemplar.cps file, Beeman exemplar CPS file. You can see the CPS path. That's kind of a way to self-reference to describe the prefix of the project. You don't have to think about that too much. Your build system will take care of that. By the way, these are almost always going to be generated by your build system. So don't panic. You're not going to have to handwrite this. But it's just encoding what it already knows. So your build system will do that to describe for other build systems, like how is your install laid out, directory laid out, basically. There's a version string. Okay, makes sense. There's include directories. Yeah, okay, makes sense. That like shocking amount of package. Like these are all things that are just assumed right now in the ecosystem. They just assume your includes are included. Okay. There's a name. Again, we talk about names being so important. It's in there because it's that important. The version is actually, the CPS version was the previous one. That's the version of the schema, right? This is the version of the package. So that's all in one file. That's it. It's at a high level, there is a Beeman library. What this on the right-hand side is another JSON file that would sit next to it. And it's describing, by the way, this is the debug build. What's unique about the debug build? Well, that one has the debug static library.a file. That's different. Same headers, but this one has a static build of the library. So you can have maybe a release version of this too. And your build system can figure that out. It has configuration. This would map more or less to your CMake build type if you're using CMake. But you may not be using CMake, so that configuration field might be used slightly differently depending on your build system. And again, it has a name. That's it. It has a link languages. Actually, that's new. Like this is something really missing from our ecosystem is to describe, I have a .a file, what's in it? Like, is it just C++? Does it also have C code? Does it have Fortran code? Does it have a runtime from like Rust or Go or something? By the way, those generally don't, but they could explicitly say they don't. Or they could say, you should treat me like a C program, it's fine. Like these are things that have never existed. All these ecosystems, when they're trying to build these things, they just hard code flags and hope for the best. And this is going to help us get out of that habit. Instead, we can just say, it's a boring static C++ library. The JSON flies over the wire, right? Just like it does for your IDE, talking to your language server protocol about where the definition of such and such is. You don't have to think about that stuff. It knows how to plumb it. This is that kind of plumbing work. So it's pretty interesting. And it's a really good application of like these principles. Like why is it important that we model these things? Why is it important that we communicate these things to our users, to the tools that need them, right? And you get nice things out of this. We're going to get adoption of this. CMake's at some point going to turn this on by default, and then everyone can just like take a breath, and you can use CMake 4.5 with CMake 3.10, and you don't have to worry about shipping CMake scripts from one context to the other without breaking anybody. Your Bazel project can pull in your CMake outputs without having to like hard code things specific to your project, that sort of thing. There's more feature work in all of this. I mean, there's a lot in that CPS stuff, but for Beam and Exemplar, we do, like I mentioned, want to package it. So like you could install and use Beam and Exemplar if you wanted a non-standard, technically API unstable version of a thing that's already standardized. I guess you can, but mostly that's to kind of blaze the trail for all the other libraries, right? We want to simplify the development workflow. If you go in there, there's like maybe more code than you'd expect in a few places. Maybe the CI is not quite as reusable as you'd like, that sort of thing. And we definitely want to make it an actual project template. So you just click the new project button and get a foobar version up without any headaches. And that's it. That's my content. Thank you for listening. Thank you.